Okay, so a very good evening to all of you. My name is Mohit teacher, and I welcome you all on the YouTube channel of TEQIP classes. Yeah, on the TEQIP classes. This is all about me, and we were discussing. Good evening, Swami. We were discussing about the unconventional machining operations, and from last two lectures we are discussing about the electric discharge machining. So I'm just briefing you that what we have covered till now, and today is our last lecture on the EDM. So just I'm briefing you that in the first lecture, our 25th number lecture, we discussed about the we started with the content, and in which we discussed about the literature part. Okay, that where the spark is came into existence, so that we are using for it for the EDM purpose. After that, we studied about the principal part, as well as we discussed the working on that lecture. Yesterday, we discussed about the what is the material removal mechanism in the EDM process. Okay, then we discuss about the two things, means characteristics or the functionality or the properties, you can say, about the dielectric fluid and the electrode beam machining. Okay, yesterday I also briefed you at the end that there are total four types of power generators are available. Means three types are, one is hybrid, so combination of these three. But is maximum problems has been asked previously in the gate or engineering services examination from the RC type circuit. Okay, RC means that is resistance and the capacitance, or we can also say it as a relaxation circuit, or we also can say it as a Lazarenko circuit. Okay, so do not confuse it, there are three names. Okay, so today we are going to discuss about how the current is means how the current is we are measuring during the charging, during the discharging, or as well as we'll also discuss about the how much energy is dissipated during the spark. Okay, when the spark is generated or when there is a discharge. So today we are going to discuss that things, then we'll go for the numerical part. Okay, so let's start. So once again, I welcome you all on the Let's Crack the Gate along with the TEQIP faculties. So first is this analysis of the circuit is first we are considering it for the during the charging. Okay, during the charging. If you are preparing for the engineering services point of view, then complete derivation should be required. You should know about it. Otherwise, if you are preparing for the gate, just write this formula what we are getting at the end. Okay, so again this equation, one of the equation that we are using over here, from that only we are starting this complete derivation, because that equation is we get it from the circuit theory. Okay, so circuit theory, yesterday I told you that if you want to go in deep about these electric part, then better you should prefer to the friend, okay, who belongs to the belongs to the electrical engineering. So okay, but whatever the necessary things which is asked from the mechanical engineering point of view, I am covering that one. Okay, so what is the during the charging, basically this is the DC power supply. Okay, so this is negative and the positive. Okay, so this is the, if we are talking about the charging, then this is the resistance, and during the charging, so we are considering it's RC. Okay, so this is the charging. This C is basically the capacitance. So we can say that during the charging, this heat is this current is flowing over here, and during the complete charging, this complete current is passes through this one. So this is the IC, that is charging current. Okay, now once the capacitor is charged, as we have discussed, whether it's a DC or AC power supply, we are just charging the capacitor. Now once the capacitor is charged, okay, after that we discussed that we are using the pulse generator. Okay, so pulse type generator is kind of like we can use the capacitor. So whenever we want the spark, that time we just supply the power. If we do not want, means we have to collapse it, then we will just turn off it. Okay, so this is the process. So when it is first of all, if we have to supply current from the charge from the capacitor, then it should be required, means it should be required that it should 100% charge. So first what we are doing is we are charging this one, and in the second analysis we will discharge it. Okay, so first when we are charging, okay, so means current will flow in this process only. In this there is no circuit is formed we have, so there will be no meaning to pass the current over this side. Okay, so the complete current will transfer in this side only. Okay, so how many things are how many components are coming in contact? First is RC, that is a resistance capacitance. Okay, sorry, resistance during the charging, and C is basically the capacitance. Okay, so there is the equation which we get it from the circuit theory. Okay, so this is dVc upon V naught minus Vc. Don't worry, I will brief you what are these terms. Okay, equals to dt upon CRC. Okay, now dVc is basically the change in charging voltage, because initially we are setting some voltage. Okay, now after that, once the discharge is started, okay, so definitely this voltage will be down, and it will reach to some condition again. When it will reach to the minimum charging voltage, again we have to charge it. Okay, because we cannot complete discharge the capacitor. Okay, so this is the difference in the charging voltage. V naught is basically the open circuit voltage, OCV. OCV, open circuit voltage, are always be like when there is a no load. Okay, at that time we are measuring the voltage and the current. So if we are measuring the voltage, then we can say it as an open circuit voltage. If we are measuring the current, that is a short circuit current. Okay, VC is the voltage during the charging. DT is the change in time, means initially we are assuming that 0 second, at the 0 second, and when we are charging and reaching to the maximum voltage, we are considering some time, that is t. So this is dt. Okay, C is basically the capacitance. Okay, capacitance, this is always measured in the farad. The unit of this capacitance is farad. Okay, RC is the resistance during the charging, so that is measured in the ohm. Okay, so initially when there is no time, means t equal to 0 time, at that time the Vc will be equals to 0. Okay, means initially we are assuming that this this is, we are starting from the 0. Okay, now when there will be some charging, means t barabar tc we are considering, means we are charging the maximum what it can be here. So that time we are considering that Vc will become Vc star. ओके, वीसी स्टार। तो देखिए आपका जो ओसीवी है वो तो कांस्टेंट है, क्योंकि ओपन सर्किट वोल्टेज होता है। ठीक है, दैट इज द मैक्सिमम लिमिट। नाउ इसमें मैं थोड़ा सा आपको एक ग्राफ से भी ब्रीफ कर देता हूं कि जो वोल्टेज का ग्राफ होता है, यस्टरडे आई आल्सो टोल्ड यू दैट एक्चुअली जो हम इस तरह के बार ग्राफ बना रहे थे वैसा नहीं होता है। लाइक दिस इज द ओसीवी, okay, this is the voltage and this is the OCV. ठीक है, open circuit voltage. Now initially we have some voltage, okay, and then we are charging it. Okay, now this is up to this we are charging, means we are setting some limit up to that we are charging. So this is a VC star. Okay, and again then we are discharging. So this is our discharging. Okay, now there is some limit, below तो नहीं पहुंचेंगे हम लोग, उससे कुछ ऊपर ही रहता है. So this up to this we are discharging. Again this is the minimum limit that we have set. Okay, यहाँ तक पहुंचेगा, then again we will charge. तो यहाँ पे this is the minimum value, again we will charge it one. Okay, now again it reached to the maximum value, we will discharge it. Okay, so like this basically the charging and discharging occurs during in this EDM process. So this is the VC start, that is the maximum value up to that we can charge, and this is the minimum value of discharge. Okay, or we can say that is a means minimum value up to that only we can discharge this one. Okay, so this is the VD star. Again when it will reach up to the VD star, again we will charge it to the maximum charging voltage. Fine, so again this will happen up and down like that. So this is the maximum voltage up to that we are charging. It means that VC is the charging voltage and it is varying from 0 to VC star. Fine, now if we are assuming this one, then we have these two boundary conditions. First is this one and second is this one. So we can integrate both these equations from both the sides. So when we will integrate at t Vc, that is initially it is 0 and finally it will be Vc star. So this is dVc upon V naught minus Vc equals to integration from 0 to Tc. So this will be this is dt upon CRC. Fine. Now when you will integrate this one, okay, so this is nothing but dx upon x. So that will be ln x, but x वेरिएबल क्या है यहाँ पे? v नॉट तो कांस्टेंट है, वेरिएबल क्या है? vc, and vc कहाँ पे है? that is a minus x. So that will be minus ln a minus x. ठीक है, so this will be minus ln v naught minus vc, and values is from limits is from 0 to vc star. Fine. Okay, now C and RC both are fixed values, means constant. So we can take out. So this will be 1 upon C into RC, and this will be dt. So this is T. So this is varying from 0 to TC. Fine. Now just put the value of this VC over here. That there are two values. First is VC star, and then we will put the 0. So this is minus. Just keep it outside and just take it this minus over this side. So this will be equals to ln. First, when we are keeping this VC star, so this will be V naught minus VC star minus ln V naught minus 0. So it will be ln V naught. Okay, minus this is TC minus 0. So this can I write TC upon CRC. Fine. ln A minus B, but we can write ln A minus B, that is ln A by B. Okay, in the formula. So from this one, ln A is the value of this one and B is this. Okay, so this will be ln V naught minus VC star upon V naught and equal to minus TC, that is charging time, upon CRC. Fine. If we have to calculate the value of V naught, then we can write this antilog. Okay, so when you will take the antilog, so this will be like e to the power V naught minus VC star upon V naught equals to e to the power minus TC by CRC. Fine. So if you will again, so this is just divided over here and over here. So this will be 1 minus VC star upon V naught equals to e to the power minus TC upon C into RC. Fine. Now just take this value over this side, left hand side, and just take it right hand side. So this will be like VC star upon V naught, that will be equals to 1 minus e to the power minus TC upon CRC. Okay, just get the value of TC VC star. So this will be VC star will be equals to V naught, that is open circuit voltage, into 1 minus e to the power minus TC upon CRC. Okay, so this value, just keep it, note this one in your synopsis. This formula is very, very important. Fine. Now this is the maximum voltage that we can get over during the charging. Okay, when the complete charging time will be TC. Okay, now अगर मान लीजिए कि आपका हम लोग TC टाइम ना कंसिडर करके कोई रैंडम वैल्यू को कंसिडर करेंगे, मान लीजिए कहीं T टाइम पे हमें वोल्टेज कैलकुलेट करना है. So what can I write this equation like? That is VC, that will be equals to V naught into 1 minus e to the power minus T upon CRC. Fine. Because at any random time I can get the value of VC. अब वो VC at that V time T time कुछ भी हो सकता है. ठीक है. Now charging current हमें क्या calculate करना था? We have to calculate the charging current. So this charging current, that will be equals to, देखिए चार्जिंग करंट क्या होता है कि जितना इनिशियली आपका ओपन सर्किट वोल्टेज है, तो दैट इज अ नो लोड कंडीशन. ओके, तो जब आपका VC है तो ड्यूरिंग दैट टाइम आपने कितना चार्ज किया. फाइनली मैं सिर्फ वैल्यू लिख देता हूँ, ज्यादा समझने की इसमें जरूरत नहीं है. दैट इज V नॉट, that is initially what the voltage was there, minus VC. So how much changes is there, means in the voltage, that is only happen during the charging. Okay, so that is only we are taking into consideration. So upon what is the resistance, that is I equals to V by R. So this is the change in volt upon RC, that is a capacitance. Okay, so V naught is the open circuit voltage. We can get put the value of VC from here to here. So this will be equals to V naught minus just I am multiplying this one inside V naught. Okay, so this will be V naught, okay, when it will multiply with the 1, and this will be minus V naught into e to the power minus T by CRC. Okay, so this will be minus and minus over here, so that will become plus. Okay, so this is plus V naught into e to the power minus T by CRC, fine, upon RC. Fine, so this is V naught minus V naught plus V naught cancel out. What will be the remaining? This is IC will be equals to V naught into e to the power minus T by CRC upon RC. So this is the open circuit voltage, and this is RC, that is during the charging only there is this RC is the resistance. So this we can represent it by the I naught. Okay, e to the power minus T by C into RC. Okay, now this I naught is what? That is the short circuit current. Please keep in mind this thing. Okay, so this is IC. So we can get the value of charging current from this formula. If IC is I naught is not given to you, then we can get the value from here, that is V naught or RC. Fine. So this is the charging current. Please keep in mind this one. Okay, and also note down this formula. There are three formulas you have to note down. First, this one. Second, this one, which is the charging voltage, maximum charging voltage, and third one is this one. Okay, because maximum problem I have seen that, or whatever the problem that has been asked in the engineering services or the gate examination, that can be sorted out by this formula. Okay, so please write this one as well in the synopsis. Okay, by the way, from this formula only we are calculating this one. There are not separate. We are not keeping anything separate there. Okay, so if you are not writing this one, then you should write this one. But okay. So next is, let's move to the discharging part. Okay, so second, this is the second part, second analysis that we are going to move, that is during the discharging. Okay. Now during the discharging, this is the capacitor, this is RC, this is your power supply. Now during the discharging, once the capacitor is completely charged, means we are assuming that this is 100% charged. It means it has the voltage which is VC star initially. Fine. Now when we are discharging it, we are assuming that this current is flowing over here to here. Okay, this is the discharging current, that is ID. Now during the, देखिए चार्जिंग के समय में क्या था कि हमने यहाँ पे we were not working on this. Okay, we were not working on that. Now we have kept the dielectric fluid in between the gap of the tool and the workpiece. So now the complete circuit is done. Okay, complete circuit जो है वो setup हो गया. Now you can perform the operation on this one. Okay, so this is discharging, and when there is a as we discussed that like this is the cathode, which is negative side, and this is anode, which is the positive side. This is releasing the electrons, this is releasing the positive ions, and these positive ions moving toward this side, tool side, and these negative ions moving toward the workpiece side. So they are colliding, and they are in between of gap. They are creating the resistance very high, and because of that only the spark is generated. Now the resistance is there, so we are just, by the way, if you will see, मतलब कोई एलिमेंट नहीं है यहाँ पे कि you can say that okay आपने एक एलिमेंट रेजिस्टेंस सेटअप कर दिया है. No, this resistance is set up automatically there due to the movement of these ions. Okay, so this here we are considering that there is a machine resistance, and we are considering it as a RM. Okay, this RM is nothing but the machining resistance. Machining resistance. Okay, fine. So this, now this RM is there and the capacitor is there. Fine, only two terms. So first is ID, that is discharging current. Okay, now this discharging current can be given by two things. First is, if I talk about that, देखिए आपका 100% इनिशियली जो कैपेसिटर है वो चार्ज है. आफ्टर सम टाइम, मतलब कुछ टाइम के बाद, एंड देयर इज ओनली वन रेजिस्टेंस विच इज आरएम. देखिए अब इसका कॉन्टेक्ट तो है नहीं इस सर्किट में. ठीक है, सो व्हेन दिस करंट इज सप्लाइंग, इनिशियली आपका कुछ वोल्टेज है. ठीक है, तो आप उससे कितना टाइम तक आपने मतलब जो आपने डिस्चार्ज जो टाइमिंग है, आपने कितना डिस्चार्जिंग का टाइमिंग यूज किया, तो फ्रॉम दैट हाउ मच चेंज in the voltage. Okay, initially how much voltage was there and what resistance you are taking. Okay, so you can calculate the value of the discharging current from there. मतलब क्या मेरे कहने का कि मान लीजिए कि आपका कोई रैंडम वैल्यू पे आपका इनिशियली ये आपका VC स्टार है, दिस इज VC स्टार मैक्सिमम, एंड दिस इज VD स्टार. ठीक है, अब VC स्टार और VD स्टार तो क्या है, दो कंडीशंस हैं. क्या ये डिस्चार्जिंग की बात हो रही है, तो मतलब ये वाले कर्व की बात हो रही है. ठीक है, इस वाले कर्व की बात हो रही है. तो इस वाले कर्व में दो कंडीशंस हैं कि इनिशियली आपका वोल्टेज कितना है, दैट इज VC स्टार, एंड फाइनली वोल्टेज कितना होगा, दैट विल बी VD स्टार. तो हम लोग इनिशियली इन बिटवीन कहीं मान लेते हैं कि दैट इज VC कहीं पे चार्जिंग, या फिर मतलब आप इसको VD स्टार से भी रिप्रेजेंट, VD से भी लिख सकते हैं, बट आई एम जस्ट राइट, जितना ज्यादा लिखेंगे उतना ही ज्यादा कंफ्यूजन होगा. सो VC से ही रहने दीजिए. सो VC इज द चार्जिंग, मतलब वोल्टेज इन बिटवीन समवेयर, एंड व्हाट इज द रेजिस्टेंस वी आर यूजिंग. सो दिस इज RM. बाय द वे आप इसको VD स्टार से भी रिप्रेजेंट कर सकते हैं. ठीक है, ऐसा कोई दिक्कत वाली बात नहीं. फर्स्ट इज दिस. सेकंड इज लाइक ID को आप इस तरह से भी रिप्रेजेंट कर सकते हैं, दैट इज माइनस C into dVC by dt. Now क्या है मैं समझा देता हूँ आपको. dt is change in time, change in voltage. Now this change in voltage again, because this discharging is occurring from this point to this point, so this is a change in voltage is nothing but this one only, okay, from vc star to vd star, and minus c, well, c is the capacitance, and we are writing this minus sign, we are using this negative sign because v is you are discharging this one, so the capacitor value is become negative, okay, मतलब डिक्रीज होती जा रही है, जो कैपेसिटर आपका चार्ज है वो डिस्चार्ज होता जा रहा है, तो दैट्स व्हाई वी आर यूजिंग दिस नेगेटिव वैल्यू, ओके. Fine. So now both the equations represent the value of ID, that is discharging current. So if both the values representing this discharging current, then we can equate both. So when you will equate, this equation will become VC upon RM equals to minus C into dVC by dt. Okay. Now just I'm just manipulating the terms, that is I'm keeping this one over here, okay, and just taking that one side. So this dvc upon vc, can I write like this, because I am vc keeping in this side, so either right hand side or left hand side, no issue, and minus dt upon, I am keeping this c over here along with rm, so this is c into rm. Fine. So this is the term. Now just we are taking again, because we have to integrate, so we are assuming two boundary conditions. First, initially when the time equals to 0, at that time the voltage is what, vc star, please keep in mind this one, okay. So this is voltage is vc star, okay. Now when the t become td, that is discharging time, discharging हो चुका होगा, that time what will be the voltage, that is vd star, ठीक है. So this vc will become vd star, please keep in mind this one, okay. आप अगर ग्राफ याद रखेंगे तो ज्यादा अच्छा रहेगा आपको, ठीक है. That is so now just integrate both the sides and put the value that this VC initially the voltage is VC star and finally it will be VD star. This is dVC upon VC equals to initially there is 0 time and we are reaching up to TD, that is discharging time. So minus DT upon C into RM. Okay. So now ln dx upon x, so that is ln x, simple है, ठीक है. Upon in this side, right hand side, this is dt है, c and rm constant है आपका, so again it will become the same thing. So this is ln vc. Fine. So the value is from vc star to vd star, ठीक है, that will be equals to minus t upon c rm, okay. So the value is from 0 to td, ठीक है. So this will become, sorry, this will become, so this will become ln first, that is vd star, ठीक है, minus ln vc star, ठीक है. Next in this side it will be minus td minus 0, so that will be, can I write minus td simply, this is minus td upon c into rm, ठीक है. Now ln a minus b, again this is what we used in the last time, so this will be like ln a by b, so this is ln vd star upon vc star, ठीक है. So that will be equals to minus td by c into rm, ठीक है. e ले लीजिए और एंटीलॉग ले लीजिए, so this will be vd star upon vc star, that will be equals to e to the power minus td upon c into rm, ठीक है. So now we can get the value of vd star from here, so this will be equals to vc star into e to the power minus td by c into rm, ठीक है. Now this value is again we are getting when the time completed, मतलब जितना टोटल टाइम जो है आपका that is discharging में है, so this voltage again the minimum voltage that we are getting during that time. तो अगर कोई random value हमें लेनी है, so I can write like this, that is VD will be equals to VC star, because overall आप VC star की value को ही क्या करते जा रहे हो, कम करते जा रहे हो, ठीक है. So into e to the power minus t upon c into rm, ठीक है. So you can use this one. Fine. Okay, so what we have done is here we use this equation. So this is id equals to vc upon rm. So vc जो है आपका that is वोल्टेज था, लाइक इन बिटवीन एज आई सेड इन द मेंशन इन द बिगिनिंग दैट इस बिट इनके बीच में कहीं पे भी आपका वोल्टेज हो सकता है, ठीक है। सो लाइक इफ दिस इज द वोल्टेज, ठीक है, ये आपका वोल्टेज है कहीं पे इन बिटवीन, सो ID will be equals to that is VC, और इसके जगह पे आप VD भी लिख सकते हो, ठीक है, दिस इज VD बाय RM। RC नहीं आएगा, प्लीज कीप इन माइंड, जब चार्जिंग होती है तो RC आता है, जब डिस्चार्जिंग है तो RM आएगा, मतलब मशीनिंग रेजिस्टेंस, ठीक है। सो दिस विल बी इक्वल्स टू VC स्टार इनटू e टू द पावर माइनस t by C into RM upon RM, please keep in mind. So this will be the discharging current, fine. Now please keep in mind that आप इसको V नोट से रिप्रेजेंट नहीं कर सकते, ठीक है, because this is not the RC, okay. So this is the current this is the current that we are getting during the discharging, ठीक है। So I think both is clear to you. We are moving to the third one, okay. Let me complete this third one. If you have any doubt you can ask me after that, okay. So third is we are moving, and in the third analysis we are just calculating the energy dissipated during the discharge to generate the spark, okay. Energy dissipated to generate the spark, ठीक है। नाउ एनर्जी हमेशा हम पावर किससे रिप्रेजेंट करते हैं, जो एनर्जी हम डिसिपेट करते हैं, मतलब जब हमें वोल्टेज और करंट दी होती है, टाइम दिया होता है, तो I स्क्वायर इंटू RT, ठीक है। तो यहाँ पे क्या है कि देखिए आपका जो एनर्जी है ड्यूरिंग द डिस्चार्जिंग, मतलब मैं एनर्जी डिसिपेटेड टू जनरेट दी स्पार्क। अब स्पार्क कब जनरेट होगा, जब आपका डिस्चार्ज होगा, क्योंकि मैंने क्या कहा था आपको कि लाइक ये जो आप जब चार्ज कर रहे हो तो ड्यूरिंग दैट आपका कैपेसिटर क्या हो रहा है, चार्ज हो रहा है, ठीक है। आपका ये जो सर्किट है ये अभी तक बना नहीं है, मतलब दिस कंप्लीट करंट इज यूज्ड टू चार्ज द कैपेसिटर, ओके। नाउ व्हेन यू आर यूजिंग द डिस्चार्जिंग करंट, एट दैट टाइम द करंट डिस्चार्जिंग करंट इज मूविंग इन दिस सर्किट, सो एट दैट टाइम now we are using this dielectric fluid, so the circuit is completed and gap is filled with this dielectric fluid. So डिस्चार्जिंग कब, स्पार्क कब जनरेट होगा, जब आपका डिस्चार्जिंग होगा। तो ये जो एनर्जी डिसिपेटेड है ये ड्यूरिंग दी डिस्चार्जिंग ही है, प्लीज कीप इन माइंड, ओके। सो दिस ED दिस विल बी इक्वल्स टू इंटीग्रेशन दैट इज I स्क्वायर, दैट इज I आप कौन सा लेंगे, चार्जिंग वाला लेंगे या डिस्चार्जिंग वाला, दैट विल बी ऑफ डिस्चार्जिंग, ओके, क्योंकि डिस्चार्जिंग के टाइम पे हम एनर्जी फाइंड आउट कर रहे हैं। सो दैट इज ID स्क्वायर इनटू R कौन सा आना चाहिए, RM या फिर RC, so this will be RM, okay, that is a machining resistance, ठीक है। So this will be RM into DT, ठीक है। डिस्चार्जिंग का सर, राइट, डिस्चार्जिंग मींस जो मशीनिंग का है, ठीक है, दिस इज RM machining resistance, okay. Now we are using this current, so we are initially means this complete energy is dissipated during the discharging only. So initially when there is no energy dissipated, and at the end the discharging time is there, that time complete energy is dissipated, so we are calculating that one. Now देखिए ID की जो टर्म है, now recently we have calculated, so this ID has the term of time in t, so just put this formula over there, okay, this formula. So when you will put this formula, this will be like 0 to TD, and this will be like VC star into e to the power minus t by C into RM upon RM square into RM into dt, ठीक है। Now from integration from 0 to TD, okay, and this will be like VC star square, so this will be like VC star square into e to the power minus 2 हो जाएगा, e to the power minus 2t by C into RM, या फिर e to the power minus t by C RM का होल स्क्वायर करेंगे तब भी पावर क्या होगा, दोनों मल्टीप्लाई हो जाएगी, ओके, अपॉन RM स्क्वायर, ठीक है, into RM into dt, so this will be cancel out, ठीक है। now यहाँ पे क्या है, e to the power minus t है यहाँ पे, तो इसको तो हमें इंटीग्रेट करना है, constant क्या हो जाएगा, first this one and in the numerator this one. Okay, so this I'm just taking this outside. Okay, so this is ed will be equals to from sorry vc star square अपॉन आर एम, ठीक है। और इस ठीक है, एक बार लिख देता हूं मैं पहले, 0 टू टी डी e टू दी पावर माइनस 2t बाई सी इंटू आर एम इंटू डी टी, ठीक है। तो e टू दी पावर माइनस एक्स, e टू दी पावर x का डिफरेंशियल इंटीग्रेशन क्या होता है, e टू दी पावर x ओनली, माइनस एक्स है तो क्या होगा, माइनस आगे आ जाएगा, e टू दी पावर माइनस एक्स हो जाएगा। और अगर कोई टर्म्स है जो उसके अलावा है, x के अलावा है वहां पे, तो उसको क्या होगा, आपको डिफरेंशिएशन करके नीचे डालना पड़ेगा, ठीक है। सो सिंपल, जस्ट आई एम डायरेक्टली राइटिंग दैट इज vc स्टार स्क्वायर अपॉन आर एम, ठीक है। और दिस इज e टू दी पावर माइनस 2t बाई सी इंटू आर एम, ठीक है। आपकी वैल्यूज कहां से होगी, 0 टू टी टी, और t के अलावा जो टर्म्स है दैट इज माइनस 2 बाई सी इंटू आर एम, ठीक है। सो दिस विल बी लाइक ed that will be equals to vc star square upon rm into minus c into rm by 2 into फर्स्ट यहाँ पे td रख दीजिए, सो दिस इज e टू दी पावर माइनस 2 td by c into rm, ठीक है। और e to the power 0, so this will be 1. Okay, now this will be cancel out. Okay, and minus I am taking inside, so this will become 1 minus e to the power, and what is remaining over here, that is ed will be equals to 1 by 2 into c into vc star square into 1 minus e to the power minus 2 td upon c into rm, ठीक है। So this will be like the total energy dissipated during the discharging, or the energy required to generate the spark. Please keep in mind this one. Okay, so if you have any doubt you can ask me, I'm just waiting for 2 minutes. So Miranjan, then we'll move to the numerical part. Okay, so that will be interesting. Fine, let's move. ओके, देखिए कुछ प्रॉब्लम्स ऐसी हैं जो अभी तक आई नहीं है, बट मुझे बुक्स में मिली, सो दैट्स व्हाई आई प्रेफर दिस वन. In RC type generator, the maximum charging voltage is 80 V. So maximum charging voltage क्या होगा आपका, VC star, ठीक है। The capacitor, the charging capacitor is 100 microfarad. F is farad, okay, and micro, that is 10 raised to power minus 6. So the value of C is given to you, that is 100 microfarad. So determine the spark energy, means again the energy dissipated for that is required for the spark. So that is the spark energy we have to calculate. Now in the this one we calculated this energy equation, ठीक है। Now in this equation there is a TD term is also there, C is also there, RM is also there, but we do not have other formula, so we have to use this one only. So what we have to assume it that if by the way, if you will calculate this value, then this value will be very minute. Okay, this value will be very minute. Okay, so whatever the means if this value is very minute, it means this will be equals, this complete value will be equals to 1 only. Okay, so if this is equal to 1, then can we write this equation, that is ed will be equals to 1 by 2 c into vc star square, we can directly use. Okay, so just use this value, that is ed, that is energy required to dissipate during the discharging, or for the sparking energy, that will be equals to 1 by 2 c into vc star square. Okay, so this will be like 1 by 2 into C. C is capacitor, so this is 200, sorry 100. This is 100 into 10 raised to power minus 6 into VC star. VC is how much? That is 80 volt. So tell me the value. So Miranjan, are you calculating? This is 100, okay, not 200. 100. Yeah, right. This is 0 point. I'm also getting the same. That is 0.32. Whatever the value that we are getting, because that is representing the energy. Okay, so we will write the unit, that is joule. Okay, please keep in mind this one also. So is it clear? Let's move to the next one. Okay, so RC type generator to get maximum power dissipation during charging, VC star will be equals to 0.716 V naught. Okay, so this is the uh, voltage is given to you. Means VC star is what? That is the maximum charging voltage, and V naught is what? That is a OCV, open circuit voltage. Determine the idle time for the resistance कैपेसिटेंस मतलब आरसी आपको चार्जिंग कैपेसिटर रेजिस्टेंस दिया है, दैट इज 10 ओम, एंड कैपेसिटेंस जो है आपको दैट इज 200 माइक्रोफैराड. ओके, सो देखिए टाइम कैलकुलेट करना है, सो मींस चार्जिंग के टाइम ही हमें टाइम कैलकुलेट करना है, सो दैट विल बी ओनली द आइडल टाइम. So if we have to calculate the charging time, so last time I told you that just write that formula during the charging. Okay, this formula. Okay, this formula. So V naught we have, so please write this formula. Okay, so from this one, this formula will be ln V naught minus Vc star upon V naught. Okay, that will be equals to minus Tc upon C into Rc. Okay, so all the values is given to you, we just have to calculate the value only. Okay, so that is ln V naught. V naught is not given to you, so just keep it as such. Vc star is equals to 0.716 into V naught upon, again V naught is same, so this V naught will be cancelled out, and overall that will be equals, what will be remaining, 1 minus 0.716 only. Okay, so that will be equals to minus Tc जो हमें calculate करना है, and C is, that is 200 into 10 raised to power minus 6 into Rc. Rc is how much? That is 10 ohm. Okay, so please calculate the value from here. Just do not multiply this 10 raised to power minus 6. That we are keeping as such. Okay. Okay, so what I am getting is, but this will not be minus, Somranjan. I was thinking like there was a plus or minus, because whatever the value that you are getting here, na, like in this one. Okay, so this value is less than 1, because 1 minus 0.716 is what? That is 1 minus 0.716. That will be equals to 0.284. Okay, so this value will be 0.284. So that is ln 0.284. So whatever the value, if this value is less than inside the ln, so then answer will be negative only. So if you will get negative answer over here, then negative will be cancelled out. This side is also minus is there. Okay, so that will become plus only. Okay, by the way, value is correct. Okay, so this is 17.56. Okay, that is into 10 raised to power minus 6 second, or if I am keeping this micro, that is 10 raised to power minus 6, so this I can write this is 2517.56 माइक्रोसेकंड. ओके, और अगर इसकी एक टर्म और है देखिए, हम इसको मिली सेकंड में भी लिख सकते हैं, तो दैट विल बी मिली मींस 10 टू पावर माइनस 3. तो उस केस में क्या हो जाएगा, दैट इज माइनस 2.51756 मिली सेकंड. ओके, सो 10⁻³ जो है वो यहाँ पे 1 2 3 यहाँ पे शिफ्ट हो जाएगा, ठीक है। So this will be the answer. Fine. Let's move to the next problem. So this problem is asked in the GATE examination. Okay. तो ये जो प्रॉब्लम है ये मैं आपको होमवर्क के लिए दे देता हूँ, ठीक है। उसके बाद की दो प्रॉब्लम मैं करा देता हूँ, ठीक है। So this problem you should consider in homework. Fine. Easy है, ज्यादा नहीं है टफ। ये प्रॉब्लम बहुत अच्छी है, ठीक है। So let's move in EDM process. Okay. In an EDM process using RC relaxation circuit, 10 mm, okay, at 10 mm diameter, means diameter आपको given है, that is capital D, through hole is made in a steel plate of 70 mm thickness. So means देखिए thickness को हम small t से represent करते थे, but यहाँ पर क्या है कि small t से हम time को represent कर रहे हैं, तो मैं यहाँ पे capital T लिख देता हूँ, ठीक है। capital T is representing the thickness or the depth, okay, 70 mm. Using a graphite tool and kerosene as a dielectric fluid, assume discharge timing to be negligible, ठीक है। जो TD है उसको हम negligible consider करके चलेंगे। Machining is carried out under the following conditions, that is जो conditions है that is given to you, that is machining resistance means that is 10 ohm, so the value of Rm is given to you, that is 10 ohm. The charging resistance is 50 ohm, that is Rc is given to you, that is 50 ohm, okay. The capacitance, that is value of capital C is given to you, that is 20 microfarad, okay. The voltage characteristics represented in a figure. Calculate the time for one cycle in millisecond and average power output, okay. तो देखिए हमें पहले सबसे पहले चार्जिंग टाइम कैलकुलेट करना है, उस पर फोकस करते हैं। तो देखिए इसमें चार्जिंग टाइम के लिए, ठीक है, तो देखिए इसमें अगर मैं इस ग्राफ को देखूं, दिस इज द V, ओके, ये आपको V वोल्टेज को रिप्रेजेंट कर रहा है, दिस इज रिप्रेजेंटिंग द टाइम, ठीक है। तो ये जो है आपका, दिस इज लाइक लास्ट टाइम भी मैंने बनाया था यहाँ पे, लाइक दिस इज योर OCV एंड ये आपका यहाँ तक आपने चार्ज किया, ठीक है, बहुत ज्यादा है बट प्लीज डिफरेंस हम मान के चलिएगा, ठीक है। अगेन जो आपका दिस इज VC स्टार, ठीक है, ये आपका VD स्टार है जहां तक आप मिनिमम डिस्चार्ज कर सकते हैं। अगेन इट विल यू हैव टू चार्ज एंड अगेन डिस्चार्ज, ओके। सो दिस वैल्यू अगेन VC स्टार एंड दिस वैल्यू विल बी VD स्टार, ठीक है। सो VC स्टार जो है, ओ सॉरी, यहाँ पे V नोट जो है आपको दैट इज 220 वोल्ट दिया है। VC स्टार की जो वैल्यू है दैट इज 110 वोल्ट दी है, एंड VD स्टार के आप कितना मिनिमम डिस्चार्ज कर सकते हैं, दैट इज 70 वोल्ट, ओके। सो दिस इज 220, 110 एंड 70 वोल्ट। नाउ दिस इज द चार्जिंग टाइम, ठीक है, this is the TC, that is charging time, and this is TD, okay, this is TD। but आपको so what you have to calculate the cycle time for मतलब one cycle, okay, and you have to assume that discharging time is negligible, so the cycle time, that is T cycle, will be equals to TC, the time taken during the charging plus time taken during the discharging। तो ये आपको negligible consider करके चलना है, so this value will be equals to TC only, okay, so please keep in mind this one। now what we have to calculate, that is TC। तो TC के लिए देखिए हमारे पास जो फॉर्मूला है that is ln V naught minus VC star upon V naught equals to minus TC by C into RC, ठीक है। तो देखिए V naught जो है that is 220 वोल्ट आपको गिवन है, VC स्टार आपको 110 वोल्ट गिवन है, ठीक है। TC हमें कैलकुलेट करना है चार्जिंग टाइम, C कैपेसिटेंस की वैल्यू आपको गिवन है, RC की वैल्यू आपको गिवन है, सो जस्ट पुट द वैल्यू, सो दिस विल बी सॉरी, okay, so ln first, that is V naught, that is 220 volt minus VC star, that is 110 upon V naught, that is 220, that will be equals to minus TC जो कि हमें कैलकुलेट करना है, upon C, that is C कितना है आपका, that is 20 microfarad, okay, so this is 20 into 10 raised to power minus 6 into RC, okay। Rm नहीं होगा क्योंकि चार्जिंग की बात हो रही है, ठीक है। सो Rm is how much, that is 50 ohm, so this will be equals to 50, okay। so from here you can get the value of TC, so please calculate the value and tell me the answer। just do not multiply here also this 10 raised to power minus 6, okay, so we will consider that in micron only। Again here also, like if you will take this one, that is 220 minus 110, this value will be equals to 110 only, okay, and 110 upon 220, so this is 1 by 2. So again this value, overall value, is equals to 1.5, means less than 1, okay. So if this value will be less than 1, then whatever the value that you will get it, that will be negative, okay, right, very good. This TC will be equals to 693. 147, right, 147, that is in 10 raised to power minus 6 we are considering, so that will be equals to microsecond, okay, and this DC will be equals to 0.693 millisecond अगर हमें मिली में रखना है, ठीक है, so that just multiply 10 raised to power minus 3, so it will shift it over here 1 2 3, okay, so that will be equals to 0.0693 millisecond, okay. Now what we have to calculate next, that is ED, तो ये आपका एक आंसर हो गया, ठीक है। नेक्स्ट व्हाट वी हैव टू कैलकुलेट, दैट इज एवरेज पावर आउटपुट। देखिए एनर्जी नहीं पूछी है आपको, पावर आउटपुट पूछा है, तो पहले हम एनर्जी फाइंड आउट कर लेते हैं, ठीक है। एंड दिस इज एनर्जी ड्यूरिंग द डिस्चार्जिंग और आउटपुट, दैट विल बी इक्वल्स टू व्हाट, दैट इज हाफ C into VC star स्क्वायर, ठीक है। देखिए अगेन यहाँ पे जो टर्म आती है, दैट इज 1 माइनस e टू द पावर माइनस 2 TD अपॉन C into RM, ठीक है। C वैल्यू भी गिवन है, RM भी गिवन है, लेकिन इसमें आपको मेंशन है कि आपका जो TD है, दैट यू हैव टू कंसीडर दिस वन एज अ नेग्लिजिबल। तो आप उसको जीरो तो नहीं कंसीडर करके चलिएगा, क्योंकि अगर आप इसको ओवरऑल को जीरो कंसीडर कर लेंगे, ये ध्यान रखना है प्लीज इसमें, क्योंकि अगर आप इसको जीरो कंसीडर कर लेंगे तो ये वैल्यू क्या हो जाएगी, पूरी 1 हो जाएगी, और 1 माइनस 1 क्या हो जाएगा, 0 हो जाएगा। तो डिस्चार्ज में एनर्जी कितनी चली गई, 0। तो हाउ इट कैन बी पॉसिबल, दैट कैन नॉट बी पॉसिबल। इसका सिर्फ मतलब ये है, डिस्चार्जिंग तो हो रहा है, बट वी डिस्कस ना दैट वी आर यूजिंग दिस पल्स जनरेटर्स। सो पल्स जनरेटर का मतलब क्या है, आप अगर देखिए, आप देखिए ये जो टाइमिंग है आप कैलकुलेट कर रहे हैं, तो ये भी आपके माइक्रो सेकंड्स में आ रहे हैं। तो जब चार्जिंग का टाइमिंग ही माइक्रो सेकंड में है, तो डिस्चार्जिंग तो बहुत माइन्यूट टाइम के लिए पूरा आपका जो चार्ज कैपेसिटर होता है वो इमीडिएटली मतलब डिस्चार्ज हो जाता है, क्योंकि स्पार्क जो है वो तो बहुत स्मॉल टाइम के लिए है, माइक्रो सेकंड्स के लिए, इससे भी कम टाइम है उसका, ठीक है। सो आप ऐसा नहीं कह सकते कि जो एनर्जी डिसिपेटेड है, फिर अगर आप इसको 1 कर देंगे तो वो पूरा 0 हो जाएगा, तो दिस कैन नॉट बी पॉसिबल, ओके। वो वैल्यू जो होगी, ये ओवरऑल वैल्यू जो होगी बहुत कम होगी, एंड एज कंपैरेटिवली 1 बहुत कम होगी, सो वी आर अज्यूमिंग दिस 1 ओनली, ओके। तो दिस विल बी इक्वल्स टू लाइक C आपको गिवन है, ठीक है। दिस इज C is what, that is 20 into 10 raised to power minus 6, and VC star is also given to you, that is 110, okay. So just put the value, that is ED will be equals to 1 by 2 into C, that is 20 into 10 raised to power minus 6 into VC, that is 110 whole square, okay. So get the value from here. Yeah, this is right, Somaranjan. This is 0.121. Again, the unit will be in joule, okay? Because 10 raised to power 6 minus 6 is already you have multiplied, Somaranjan. Please keep in mind, okay? So that will be in joule. Fine. So now we do not want the energy dissipated, okay? We want the power. तो power क्या होती है आपको, and power इसमें पूछा भी क्या है आपको, किलोवाट में पूछा है, ठीक है? तो वॉट में किस तरह से एनर्जी को हम कन्वर्ट कर सकते हैं, डिवाइडिंग बाय द टाइम। नाउ टाइमिंग क्या है आपका, टाइमिंग टोटल टाइमिंग क्या है आपका, साइकिल टाइम कंसीडर करोगे आप इसके लिए, क्योंकि डिस्चार्ज एनर्जी किस पे डिस्चार्ज हो रही है, ड्यूरिंग द डिस्चार्जिंग ओनली, मतलब तो डिस्चार्जिंग टाइम कैलकुलेट करना पड़ेगा। लेकिन इसमें आपको बोला गया है ऑलरेडी प्रॉब्लम में कि यू हैव टू कंसीडर दिस एज अ नेग्लिजिबल। तो टोटल साइकिल टाइम क्या है आपका, दैट विल बी इक्वल्स टू TC, ओके। सो जस्ट गेट द वैल्यू ऑफ पावर, दैट इज एवरेज पावर output will be equals to ED, that is 0.121 joule, ठीक है, upon this is just put in second, so this will be like 0.693 into 10 raised to power minus 3 second. So this joule per second will become watt, okay, and this 10 raised to power minus 3 है, नीचे है, तो आप उसको ऊपर ले जाएंगे तो into 10 raised to power 3 हो जाएगा, ठीक है। So this that is in watt, and this 10 raised to power 3 will become kilowatt, okay। तो आप जब इसको कैलकुलेट करिए सोमरंजन, that is 0.121 upon 0.693, इसको कैलकुलेट करिए। Yeah, right. 0.1746, right, that is in kilowatt. Very good, very good, very good, very good. Okay, so this is in kilowatt. ठीक है, so this is your fine second answer. ठीक है, एक छोटी सी प्रॉब्लम है, ये और कर लेते हैं, ठीक है, फिर उसके बाद खत्म है. So a circular hole, diameter आपको given है, that is 25 mm. ठीक है, depth of that depth दी है आपको, means thickness दी है, that is capital T we are assuming here again, that is 20 mm. This problem has been asked in GATE basically in 2018. Okay, in machined by the EDM process, and the material removal rate is in mm cube per minute is given to you, and it expressed as okay, material removal rate MRR, that will be equals to what is given to you, that is 4 into 10 raised to power 4 into I into T raised to minus 1.23. ठीक है, देखिए where I is equals to 30 ampere. ठीक है, and the melting point of that is T is equals to 1600 degrees centigrade. Okay, time in minutes for the machining this hole is correct up to 2 decimal find out करना है, मतलब points के बाद 2 decide NAT में पूछा गया है. ठीक है, तो देखिए इसमें क्या करना है आपको. फर्स्ट ऑफ ऑल यू जस्ट कैलकुलेट द वैल्यू ऑफ MRR. ठीक है, नाउ आपको यहाँ पे क्या है कि आपको कैलकुलेट क्या करना है, टाइम कैलकुलेट करना है. ठीक है, तो देखिए मटेरियल रिमूवल रेट होती क्या है कि हाउ मच अमाउंट ऑफ द मटेरियल इज रिमूव्ड, मतलब आइदर या फिर केजी में, ग्राम में कैलकुलेट कर सकते हो, केजी ग्राम में, या फिर वॉल्यूम में, मींस मीटर क्यूब, सेमी क्यूब या फिर mm क्यूब, तो उसमें कैलकुलेट कर सकते हो. यहाँ पे वॉल्यूम जो है आपको डायमीटर और डेप्थ दी है. ठीक है, तो जो डायमीटर है उसको 25, ठीक है, डेप्थ उसका 20 है, तो पाई बाय 4 इंटू डी स्क्वायर इंटू टी करके आप टोटल वॉल्यूम कैलकुलेट कर सकते हो. नाउ what is MRR, that is how much amount of the material removed per unit time, so from that you can calculate the value of time. Easy है. ठीक है, so the first we are calculating the value of MRR, so that will be equals to 4 into 10 raised to power 4 into I, that is just put the value directly, that is 300 into T, that is 1600. देखिए अब यहाँ पे एक कंडीशन, एक ये है कि यहाँ पे जो T है आपको ऐसा लिखा है डायरेक्ट, वेयर I is equals to 300 एम्पियर and the melting point of the material is 1600 डिग्री सेंटीग्रेड. ठीक है, तो हम डिग्री सेंटीग्रेड में ही कंसीडर कर रहे हैं उसको. ठीक है, सो जस्ट दिस विल बी 1600 raised to minus 1.23. so please quick tell me the answer of this, मतलब value of this one, not answer is not MRR. so whatever the value that we will get, that will be in mm cube per minute only. Okay, very good, let me check. Yeah, very good, this is 1374.40. okay, so this is the value that we are getting. Okay, very good. Now this is the MRR. We have to calculate the time, so the time will be equals to how much volume we have calculated upon with respect to the MRR. Okay, so the volume will be equals to pi by 4 into d square. D is how much, that is 25 whole square into volume, depth is 20. Okay, upon MRR, so this is 1374.40. okay, now volume is also, this is in area, that is in mm, diameter, and the depth is also in mm, so that will be in mm cube. Okay, and this is in mm cube per minute, so whatever the value that you will get, that will be in minutes. Okay, and final answer is asked in the minutes only, so just get the value from here. So this time will be equals to, that will be in minutes. Okay, so tell me the value. 7.143. okay, means we have to calculate up to 2 decimals, so this will be like 7.14. okay, so this is in minutes. Fine, so this will be the answer. Easy है. ठीक है, देखिए शुरू में थोड़ा ऐसा था कि लाइक एनालिसिस जब कर रहे हैं तो इलेक्ट्रिकल एनालिसिस है, क्या समझ में आएगा कि नहीं आएगा, लेकिन नाउ वी हैव डन दैट इन फॉर्मूला आल्सो, वी हैव सीन दैट एंड न्यूमेरिकल प्रॉब्लम्स आल्सो वी हैव कंडक्टेड. सो आई थिंक आप थोड़ा ये इजी लग रहा होगा. ठीक है, अब इसके अलावा कोई प्रॉब्लम्स अगर ईडीएम में है तो आप वो कर सकते हैं. ठीक है, one more thing is here that actually from past 2 days I am little bit busy in some of the training program, and I will be continue this this program will be next week as well. So I will start I still have to consider discuss 2 of the machining processes and non-conventional machining, that is abrasive jet machining and the ultrasonic machining. And I have to take other topic which I have left, that is the miscellaneous part. So that is 3 to 4 lectures are still remaining. So that I will conduct after that. Okay. So thank you so much, guys, and good night. See you soon.